Namaskar. Welcome to the CTET preparation mathematics pedagogy class. So I am Manohar H, Senior Research Fellow, Department of Education, RIE, Mysore. So in this session, which is a very important session, okay, in the mathematics, the topic is we are going to discuss error analysis. So this topic is very much important in mathematics. So that majorly we are going to cover in this session. Classification of the errors and types of the mathematical errors and error diagnosis and remediation and the teaching methods to reduce the errors and some of the previous CTET year questions we will see and try to see that how the questions they are asking, and latest CTET pattern questions we will also see in this session. Okay, so I'm then going to the next one. So if you observe the question-wise analysis from the past previous CTET question papers, the kind of questions they're asking, and based on these concepts. Okay, so in every year, if you observe from the 2011 to 2016, every year in the CTET paper 1, paper 2, minimum they are asking 2 to 4 questions from this concept. So hence this concept is very much important. Okay, so what are the topics we are going to cover in this session, especially conceptual error and the procedural error, careless error and error analysis, and what misconceptions and teaching strategies, and what are the teaching methods are there in order to overcome the misconceptions, and the learning through the errors. So how we can, a child can learn, through the errors. And remember, in the CTET, if you observe the previous question papers, it never asks only the definitions. It asks identify the student's misconception and the best, after identifying the misconception, what is the best teacher response, remedial teaching we provide for that, which is the most suitable pedagogy in order to overcome the error analysis errors. So what are the error types students are committing when they are solving the mathematical problems, and what are the appropriate teaching methods. So about these, majorly focusing on CTET paper 1, paper 2 of this chapter. Okay, so focus understanding the errors and analyze the thinking and choose the right pedagogy and improve the learning. This is a major theme of this error analysis of the unit. So next, so if you see the previous year question, okay, students make errors while solving mathematical problem because that is the question which they asked. The question is like this: the students make errors while solving mathematical problems because why students makes the error while solving the mathematical problems. Let us see the options. What are the options they have given? The option A is they do not refer multiple books. Option B, socio-economic status affects the performance. And the option C, they make alternative interpretations of concepts while making meaning. Option D, they do not practice enough. So which is the correct answer? Let us see now. Try to understand option by option. Now if you see the option A, it's saying that the statement is saying that they do not refer multiple books. Does it possible? No. Students, they refer various books in order to acquire the knowledge, in order to improve their knowledge. So referring the multiple books may help improve the knowledge, but errors in solving mathematical problems are not the primarily due to the referring of the number of books. So but the focus mainly on understanding the concepts, not the number of the resources. Okay, so therefore this is also not correct for the given question. So basically the student, they refer the multiple books in order to acquire the improve their knowledge. Okay, next coming to the socio-economic option B. Option B, socio-economic status, it affects the performance. Okay, so let us see whether it is correct or not. So while socio-economic status can influence the educational opportunities, it is not the direct reason for errors to made the while solving mathematical problems. So if you see that, okay, if a child who is having the economically good, so they may get the access of the good education. So whereas the child would not having the good socio-economic status, you may not get the access of good education. So therefore it doesn't affect the performance in making the mathematical problems error. So the option 3 is they make alternative interpretation of the concepts while making meaning. So this will be the correct answer for the given question. Students make errors while solving mathematical problems because they make the alternative interpretation of the concepts while making meaning. So students, they come up with the previous knowledge. They do not come up with like empty results. Okay. They often create their own meaning of interpretation, whatever they have learned from the classroom during teaching learning process. Okay, so if a student study any concept, okay, which they try to interpret in their own understanding. So when they try to interpret their own understanding, they may interpret, sometimes they may interpret, the interpretation may be correct, sometimes the interpretation may be wrong. So which may be different from the standard or mathematical meaning. So for that, so when they try to interpret in a when they try to interpret whatever they have learned, so it leads to the errors. So it leads to the errors. Okay, so this option reflects the cognitive and conceptual nature of error making. So which is with the how students learn and construct the understanding. So this is the correct option. Now option D, they do not practice enough. Okay, so practice makes important, but errors are not only due to lack of the practice. Even with the practice, if the concept is not well understood, errors can occur. So this is also wrong answer. So which is the correct answer? No, option C is the correct answer, where they make the alternate interpretation of concept while making meaning. So with that, students make errors while solving mathematical problems. Now, let us discuss about the relevant concept of this question. Children, they not come to the classroom with the empty vessels, where according to constructivism, children they create their own understanding based on the concepts they have acquired, and based on the information, the knowledge they acquired, the information, and sometimes this understanding may be incorrect, sometimes the understanding may be correct. So the when the understanding become incorrect, so that leads to the misconception. When misconception is becomes a error. Okay, so as a teacher, we should provide a alternative remedial teaching for this. Now, as a teacher, what we have to do? First, we have to observe. Okay, and then where the student is committing the errors. Okay, so then you have to diagnose why student is committing the mistakes. Okay, then we need to discuss with the students. Okay, so where is the problem? We need to identify what exactly the student is trying to commit the mistakes, or where it is not understanding, the child is not understanding, he or she, whether it is a conceptual error, whether it is a procedural error. Okay, what kind of error is child is trying to make, and then with a proper remedial teaching, we need to correct, we need to overcome from the mistakes, so rather than punishing. Okay, so errors are the opportunities for the learning. And then the next question is, Salman solves -3 plus -4 equal to +7. Okay, so the error is lack of practice, option A. Option B, doesn't know multiplication. Option C, carelessness. Option D, not clear about addition of the integers. Now, what is the question is trying to ask? There is a one student, Salman. He solved the given equation like this: -3 plus -4 is equal to +7. But when he solved this this problem, okay, there is a something error. So now the question is asking, you need to identify what type of error it is. Okay, whether it is a lack of practice error, we call it that error is a lack of practice, or we call it is where child doesn't know multiplication, or it is a carelessness, or it is not clear about the addition of the integers. Now let us try to understand each and every one. Okay, so what is the meaning of error of the lack of practice here? Okay, so it's not about the practice. The student is confident but applies the wrong rule here. So that means students, you should understand the concept here. So what is the concept involved here? Where the two negative integers are added, so when the two negative integers are always, it always say negative. Okay, so that is what, but where the student what has done here, he has done the positive. So that means it is a not clear about the addition of the integers. Okay, option D is the correct one. Okay, now why not the option B, doesn't know multiplication? So now here, does when the student is trying to solve, is there any multiplication involved here? No. So we are only involved addition and subtractions. Okay, now carelessness. Option 3 is the carelessness. The student has not made any small mistake here, so he has applied a wrong rule. Okay, so in the calculation part, he has applied only the signs only here. Sign whatever minus minus plus, the signs are negatives. He applied the wrong signs. Okay, so application of the concept is correct here. So option B is the correct for this. Not clear about the addition of the integers. Now coming to the next one. So in the error analysis process, okay, we need to observe the error first, identify the pattern. So in a series of observation, what kind of error is trying to commit the student, and then find the reason for that. So why error is making? Is it because of the carelessness? Is it because of not understanding the concepts? Is it because of the lack of the practice? Why? And then correct the concept and reassess again whether it is a student whether making the error or not. Okay, so now error analysis, which helps in building the conceptual understanding and developing accurate mathematical thinking. So it helps to develop the building the conceptual. So the more the student do the error analysis, they try to develop the more conceptual understanding of the concept, and through that they try to develop the accurate mathematical thinking. Now the next question is a common error 5y plus 3 is equal to 8y. So this is dash, whether it is a clerical error, option E, option B is a conceptual error, option C is the procedural error, option D is the careless error. Now the question has given a common error which is made by the committed by the students, and we need to identify that whether it is a what kind of error, the types of error. Okay, so whether it is a clerical error, whether it is a conceptual error, whether it is a procedural error, whether it is a careless error. Now let us see the option A. Okay, clerical errors are the small mistakes in writing or copying numbers. So here, if for example, if you see here, for the question 5y plus 3 is equal to 8y. 8y. Okay, so here the student has changed the expression itself. Okay, if the write 5 plus 5 3 as a 5 minus 5 3, then we say that it is a clerical error, where in a small mistakes in writing or copying the numbers or the signs. Okay, so here there is no clerical error because the signs are correct here. Okay, so then that means this is the wrong. Okay. Then next one is the conceptual error. Okay, so the student does not understand the concept of the like terms. He thinks 3 can be combined with 5y and write it as the 8y. So this shows the wrong understanding of the concept. So if you see that, okay, in the concept here we have a expression 5y plus 3 is equal to 8y. So 3 is the constant. Okay, there are two terms which are involved here, and 5 is another term. Okay, so when you try to do the calculation, you think that okay, so 3 constant terms can be written as a together, which leads to the misunderstanding of the conceptual error. So therefore we can say that option B is the conceptual error, where he doesn't have the understanding of the concepts, therefore together he combined and has written the expression like this. Okay, so the next one is procedural error. The procedural error means it occurs in the steps of the solving. So here in this problem, student does performing any calculations. The child is doing any operations here. No, so here the error is understanding the concept itself only. Okay, there is no performing problem solving is not involved in this question. Okay, careless error. Careless errors are the unintentional slips. Okay, unintentional slips like missing the signs, miswriting the number. Here the student is confronted in the wrong area but not a slip. So he has done the correct only. Only the thing is that where he has not understand the concept. Okay, so but missing the signs everything is signs and miswriting the numbers everything are correct only. So therefore we say that only the conceptual error is committing the error. So this common error is which leads to the conceptual error. Option B is the correct. Now, so what is the concept which is involved here? The like terms can be added and subtracted, and the constants cannot be combined with the variable terms here. Okay, where we have here constant and terms, it can be combined together, but where student has committed, added both. Okay, so 5 and 3 are the unlike terms, they cannot be added to become a 8y. Okay, so this is the purely conceptual error. So now let us come to the types of mathematical errors which are involved. Okay, so there are 4 types of mathematical errors are there. The first one is the conceptual error, and the second one is the procedural error, and third one is the careless error, and the fourth one is the computational error. So what does it mean, the conceptual error? Okay, where the student is trying to wrongly understanding the concepts. Now as we discussed in the previous one of the question, 5y plus 3 is equal to 8. Okay, student thinks that 5y is equal to 8y. So y becomes a 0 line. So this is a concept, understanding the concept is very wrong here. Okay, where we have the different terms, constant is there, terms are there. So that is trying to add constant mixing with the constant with term. So therefore we can say that the concept understanding is very wrong here. Now procedural error, correct concept, wrong steps. Okay, so when now suppose let us take is child is trying to solve this problem like this. Okay, 2 into x plus 3 is equal to 10. Okay, 2x plus 3 is equal to 10. Is this a correct one? No. Okay, so then 2x here is equal to 10 plus 3. No. So here we has done the procedural error he has done. Okay, so where is the correct one? He has to multiply this with the 2 and then we need to solve that. Okay, so making problem solving and try to solve the problem, mistakes in the solving the problems. Okay, so yeah, that is the procedural error. And the next one is the careless error. Child has the correct knowledge but the wrong calculations. Now 2 plus 2 is equal to 5. So he has the idea about that where it, these two integers need to be added. Additions concept he has to apply. But so what he has done here, the 2 plus 2 is equal to 5. Okay, so that means he has the correct knowledge about calculation part. He has done the wrong. So that means with a carelessly careless error he has committed here. Okay. Similarly, like 47 plus 30 is equal to how much? 47. 38 has written 30 plus 8, but okay, in the calculation part, so what outcome, final product, what he has done, it has done this, he has calculated as the 75. So that means it is a calculation mistake. Okay, so this is what the careless error we can say that. Okay, computational error, basic operations mistakes like 36 into 7. Okay, the student write as a 36 into 242. So where answer is wrong. Okay, so we can say that it is a multiplication error. Okay, so that means meaning wrong. So if the meaning is wrong, then we say that it is a conceptual error. If the steps are wrong, then we say that procedural error. Okay, if the calculations are wrong, we say that careless error. Now let us see one more example. Chaya simplified the given problem like this: minus 25 by minus 30 equal to minus 5 by minus 6. So now we need to identify what kind of the error is, whether it is a procedural error, it is a wrong interpretation, or it is a careless error, whether it is a conceptual error. Okay, option A is the procedural, option B is the wrong interpretation, option C is the careless, and option D is the conceptual. Okay, now what is the procedural error? Okay, the procedural error occurs in the steps or method of solving. So example like wrong operation, wrong order. Okay, so here the if you observe a problem that the child has done any wrong operation, no, he has done the correct only. Any wrong order, no, there is a correct order only. So here reduction is done correctly, but the sign is only wrong. So therefore this is not the correct answer. Okay, now let us see the wrong interpretation. Wrong interpretation means misunderstanding the meaning of the question or the numbers. If the child has understood the very meaning understood very wrongly, no. So whatever the calculation has done here, correct only. Here the only student understood the question correct only. So that is not that is also wrong. Now let us see the third one, careless. Okay, careless error happens due to the inattention or sign mistake. Chaya forgot the rule. Okay, where minus 24 by minus 30, where this minus also will get cancelled and becomes a positive. Okay, negative divided by negative, that becomes a positive. That is the rule where Chaya's forgot. Okay, so with that, so because of this carelessness, so he represented solution as minus 5 by 6, which is the wrong. So you know the concept, how to do the perform, how to calculate, how to simplify the concept, but only because of inattention or sign mistakes, he committed to the careless error. So option 3 is the correct one. Conceptual, let us see another one, conceptual, option D. So conceptual error means not understanding the concept at all. Okay, so here the child knows how to divide the fractions and reduce them, but the mistake is only with the signs. So he knows that how to divide the 25 by 30 and how to reduce the simplify the formula, but the only thing he committed with the signs. So this is not the conceptual clarity. Your child is having the conceptual clarity, but only the thing is that he doesn't carelessly inattention or with inattention he made a sign mistake. Now coming to the next concept discussion. So there are 6 types of classification of the errors are there. One is the personal error, which basically leads to a teacher, and the variable error, so based on the situation, and the constant error based on the tools which you are using during the teaching learning process, and the interpretive error, which is based on the analysis, and accidental error, which from the by chance, and systematic error, which is repeatedly committing the error. Okay, so the personal error means due to individual limitations such as knowledge, skills, attitude, or health. Okay, so that which leads to the, so wherever whenever they have the limitations in terms of the knowledge, skills, attitude, health, so it becomes a personal error. What is the variable error here? So that means it changes from the time to time and due to different situation, moods, or environments. Okay, that is a variable error where it change from the time to time based on the situations, between the based on the moods, based on the environments. Constant error, it remains the same because of the faulty tools, instruments, and resources. Okay, interpretive error, it arises from the wrong interpretation or analysis or data informations. Okay, interpretive error when it become when you collect the data from the different sources, and okay, when you try to do the analysis, okay, when you interpret incorrectly, then we say that it is an interpretive error. Accidental error, it occurs by the chance, not unintentionally it occurs, not by the design. Systematic error, it occurs repeatedly due to flaws in the processor method. So when you commit the mistake in the process when you're making the method, we say that it is a repeatedly systematic error is occurred here. So understanding the type of error which helps in identifying the real cause and choosing the right strategy to correct it. Now let us see another question. The question is like this. When introducing the mensuration topic, the teacher first writes all formulas on board, and then it shows that whether it is a deductive approach, whether it is experimental approach, whether it is a practical, or whether it is a inductive, which is the correct answer. Let us see now. So what is the deductive approach here? Okay, so what is the trying to ask here? When introducing the mensuration, the teacher first write the formulas on board, and then he is teaching the concept. Now if you see the deductive approach here, in the deductive approach, generally from your general in a general statement we try to do the general used to definition like formulas and then apply them to examples. Okay, teacher first present the general rules and definitions and formula and then applies them to examples. Now suppose I have a Pythagoras formula I have, so AC square is equal to AB square plus BC square. Okay, now I introduce the formula here, definition here, and then I'll take some of the values. AC is equal to some value and AB is equal to some value, BC is equal to some. Then I'll try to apply here, and then I'll try to specifically generalize that it is applicable for the even further. Okay, that is one of the deductive approach. Now experimental approach. Experimental approach means students discover the concepts through the experiments or activities first. Here teacher did not start with the exploration, where student start the exploration. Okay, so where student they discover the concepts through the by performing the activity, by performing the experiment, by through the inquiry. Okay, that is the experimental approach. Okay, so but here what they are asking here, introducing the mensuration topic, first write all the formulas on board. So which approach we try, teacher is writing the formulas when the deductive approach is writing the formulas. So therefore option A is the correct one. Okay, now option C, practical. Okay, practical approach focuses which focus on hands-on activities which manipulative or real life task. Only writing formula is not the practical teaching. So basically practical approach we say that it is based on the hands-on activities where we manipulate, where we connect with the real life task. Okay, so writing only formula is not the practical teaching, therefore this is also a wrong answer. Now let us see the inductive. Okay, inductive approach which start from the specific examples and leads to the general rule or formula. Exactly it is opposite of the deductive approach. Here in the inductive approach, what we teacher does here, he introduces the examples by taking the examples, and it will take the examples and which leads to general rules, or from the examples we try to form the rule, or we try to generalize the rule, we try to form the formula. Okay, exactly where teacher we do the opposite of the deductive approach. Okay, so deductive approach means remember general to specific, and deductive approach means specific to general, and writing formula first means teacher gives the general rule and before the examples. Okay, so which is the correct answer for this? We introduce the mensuration, teacher first write all formulas on one. So in the deductive approach only, first teacher write the formula, then try to introduce the concept. So deductive approach is the correct answer for this. So for examples, like let us try to understand what is the inductive much more in deeper, deductive and deductive. Okay, So inductive is examples here which we are discussing, like 2 plus 4 is equal to 6 and 3 plus 4 6 is equal to 9, 4 plus 2 is equal to 18, 5 plus 10 is equal to, and so on. Okay, so what is the rule they're trying to here making here? So that if you take a is equal to 2, okay, then the value 2a is equal to 4. Okay, similarly if a is equal to 3, 2a is the 3, 6. Similarly if a is equal to 4, 2a is equal to a. So what will become 3 here? 6, 9, 12. So that means we're taking the examples here and trying to form the rule based on this one. Okay, so this is what the inductive approach. In the deductive approach, exactly reverse of the inductive approach, where first we introduce the rule a plus 2 plus a is equal to 3, and based on this we take the examples and then we try to prove that the rule is in the given condition is satisfied. So here saying if a is equal to 2, then 2 plus 2, 2a become a 2 plus 2 into 2, the 3a become a 6. Okay, so this is the deductive approach. Okay, then the discovery learning. Students observe examples and discover the rule. In the traditional teaching, teacher gives the rule and show the examples. Okay, so that is what inductive versus deductive. Okay, so in the inductive reasoning we build the rule from the examples. Okay, that is the discovery. In the deductive reasoning we apply the rules to the new examples. Okay, so that means application level. Okay, so this is the difference between the inductive deductive. Now coming to the another question, GeoGebra helps students learn geometry through. There is a one question is like this: GeoGebra helps students to learn geometry through exploratory approach, inquiry approach, okay, project method, lecture method. There are 4 options as given. Option A is the exploratory approach, option B is the inquiry approach, option C is the project method, option D is the lecture method. So which is the correct answer? So what is the GeoGebra? GeoGebra is one of the instrument, one of the tool where we use in mathematics to make them to understand the concept through visualization, especially we use in the geometry concepts. Okay, now let us try to understand what is the exploratory approach, meaning of that one. So it is a dynamic geometry software, GeoGebra, where it allows the student to explore, manipulate and visualize the geometrical shapes and conjecture and relationship. This is the essence of the exploratory approach. We are providing the opportunity for the students to explore through the technology or through the using the different various tools to further understanding, for deeper understanding of the concept. So the exploratory approach is the correct one for this. Okay. Now inquiry approach. Why not inquiry approach? Inquiry approach involves where we ask the questions and we ask them to collect the data child and draw the conclusions from that. Okay, but GeoGebra support only exploration, but the focus here is not inquiry based learning. Okay, so where it support exploration through for the visualization. Okay, it is not we don't ask in inquiry approach, make the collect the data and ask the questions. Okay, focus only on to support the learning. Project method. Option 3 is the project method. Project method which involves a long-term task or investigation, which is conducted by the student to create a product. Okay, so GeoGebra is a tool, it's not a project. Okay, so GeoGebra where we use in the mathematics for the geometry, we to extend our learning for better understanding. Okay, we don't create project from the GeoGebra. So therefore this is also wrong answer. Lecture method. So lecture method is a teacher-centered method where especially during the teaching learning process where student is more focused on that than the child, and the information is mainly delivered only through the explanation. Okay, so GeoGebra is a software where it is required interactive and between the students and students and teacher, and it is a student-centered application. So therefore GeoGebra helps students to learn geometry through the exploratory approach. Option A is the correct one. So exploratory approach where it encourages the students to explore the experiment and discover the concepts. Okay. Then the next question is, write a pair of integers whose sum is negative. The question is like this: write a pair of integers whose sum is negative. What kind of question? The question is, so here the question is asking, write a pair of integers whose sum is negative, and thus whether the question is a reflective question or whether it is a closed question, whether it is a multidisciplinary question, whether it is an open-ended question. So by seeing the options we can say that, okay, by reading the question, Write a pair of integers whose sum is negative, which is an open-ended question. Okay, so but what is the reflective harmony? So here, is there any reflecting in the given question here? No. What is the meaning of reflective question here? Reflective question means it requires the students to think about their learning, their own experiences, or their beliefs. So this question doesn't ask for any reflection. It is asking for the pair of integers whose sum is negative. Okay, is it the closed question? Let us try to see whether it is a closed question or not. Closed questions basically have the fixed and specific answer. Okay, but does our question is providing a scope for the closed question? No, it is open-ended question where it is providing open. They need to write a pair of integers whose sum is negative. It may be various integers will be having. So these questions have the many correct pairs. Example like -1 0, -1 1 and -5 and -2, etc. like this. Okay, this is not a closed question, this is an open-ended question. Therefore, this is also wrong answer. Then is it a multidisciplinary question? Multidisciplinary questions connect concepts from the different subjects. This question is purely from the domain of the mathematics only. Is there any subject involved in the given question? There is no question. It is purely asking about the integers, and the sum of the integers is a negative. Whose sum is a negative. Okay, so completely purely based on the domains of the from the mathematics only. So this question is asked. Therefore, we say that it is also not a multidisciplinary question. Now open-ended. So open-ended questions have the multiple correct answers or more than one way to respond. So here many pairs of integers satisfy the conditions. Now that is what they are asking. Here write a pair of integers who satisfy the sum, their sum is negative. So that means we have the many pair of integers whose sum is satisfy the given condition. So therefore we say that it is an open-ended question. So which is the option? The option D is the correct for this question. Now, next question is the question is like this: the technology-based games in mathematics help students. Option A, understand the concepts through the exploration. Option B is assess performance. Option C is manage classroom. Option D is improve only computation. Okay, now let us try to see option each and every option. The question is, technology-based games in mathematics help the students to understand the concept through the exploration. Option A, what is the meaning of that understand the concepts through the exploration? While during teaching learning process, we use the technology, okay? We conduct the games, we use the technology. So that technology-based games provide interactive, okay? Where students enjoy, during teaching learning process when we teach concepts through the, through the technology, like which we had discussed before in the, like GeoGebra or different, various tools. And exploratory environments where students manipulate, observe and discover the patterns, where we provide opportunity for the student to explore about the concept and where they try to manipulate, they observe what's happening and they discover the patterns from the observations. So this deepens the conceptual understanding. So when they try to explore the concept through the interactive exploratory, and when they try to learn the concept through the observation, when they try to discover the patterns from the observations, which help the learner to develop the conceptual understanding much more better. So the technology-based games in mathematics help students to understand the concepts through the exploration. Assess, the second option is assess performance. Let us see what is this. While games can generate the data, their primary purpose is not the assessment. Assessment is the secondary benefit, which is not the main goal of that. Okay, assessing can be the secondary, it's not the main goal. Okay, so managing in the classroom. Games may help in classroom engagement, but they are not designed mainly for the classroom management. So it is a part of the learning process, but it's not designed only for the classroom management. Okay, so it may help in classroom engagement, but they are not designed mainly for the classroom management. Improve only computation. So technology-based games support a wide range of skills such as reasoning skills. So through the technology games, which will basically support various skills such as the reasoning and problem solving, visualization, strategy. Okay, so this all the skills will help you to develop through the when we inculcate technology in our during teaching learning process. It's not just only the computation. So improve only computation. So the option which is the technology games mathematics help the students to understand the concepts through the explanation. Option A is the correct one. Okay, so technology based games basically to promote the active learning by encouraging the exploration, reasoning and the conceptual understanding in the mathematics. Now the next one is engaging mathematics classroom, best strategy for visually challenged learners. The question is like this: in the inclusive mathematics classroom, best strategy for visually challenged learners. So the question is focused based on the inclusive education. The option A, they are given like we need to send to the special educator. Option B is a design alternative teaching learning methods. Option C, offer another subject. Option D is pair with topper. Which is the correct option? Let us see now. Let us try to understand one by one. So inclusive mathematics classroom, best strategy for visually challenged learners only when they design alternative teaching learning methods. When they send to special educator, does it learning happens there? Inclusive education means learners where they learn in the same classroom. It becomes a, so, when they send child to the special educator, he doesn't sit with a regular classroom with the same classroom with the regular students. We are not learning anything. So therefore, removing the learner from the class goes against the inclusion. So inclusion means which child should also included with the regular students. Okay, if we cannot, just sending the special educator doesn't make, best strategy for visually challenged learners. Now option B is design alternate teaching learning methods. The inclusive classrooms are required adapting the various methods based on the needs of the child. Okay, based on the needs of the child, various methods we need to adapt. Various materials is required, and assessment is need to be required based on the child's needs of the child. Okay, so like for example, like tactile aids like teaching aids and audio, braille, concrete models, which are important for the visually challenged learners. So these methods and strategy assessment techniques we should adapt to become to make it a best strategy for the visually challenged learners in a mathematics classroom. So therefore option B is the correct one, where we design the alternative teaching method along with the regular students to become much more meaningful learning. Then option C is offer another subject. It cannot be. Okay, so this denies the learner the right to learn mathematics. So we cannot offer, since child cannot learn the mathematics, we cannot offer another subject. Okay, this becomes a right to learn, deny the right to learn mathematics. Okay, this is also wrong answer. So inclusive approach means it is about providing equal opportunity for the child, not the subject change. Okay, where we provide equal opportunity for learn with the regular students. Then pay with topper. So peer support help, it will help, but not the best overall strategy. We cannot just assisting with the combining with the pair, when a pair with the topper or pair with the peer learning doesn't help you to become overall strategy to learn the inclusive mathematics classroom for visually challenged learners. Okay, she does not address the specific learning needs of the child, visually challenged learners. Okay, so therefore this is also wrong answer. Which is the correct answer is design alternative teaching learning method based on the requirement of the child. Now another question: the child repeatedly write 7 into 8 is equal to 54. Teacher should first option A, the given punish. Option B is the give homework. Option C is the identify the misconception. Option D is the ask to memorize the table. So the student has repeatedly write like this. Certainly there is a mistake here. But teacher, what we should do here? We should identify the misconception. Why student is repeatedly writing like this? What is the problem here? Whether it is what type of error is committing, what type of conceptual understanding is not there. Whether it is a conceptual understanding, whether it is a procedural understanding. So through the observation, teacher should identify that. So punishment just does not address the root of the cause of the error, but it may create a fear and reduce the child confidence. So therefore, punishment is not a solution for that. Giving homework, more practice without understanding, it doesn't make any sense. It strengthens the wrong concept, but it makes the misconception more rigid. So this is also wrong answer. Now, as a teacher, what we should do when we commit repeatedly this mistake, we should identify the misconception. The step is to diagnose the child thinking first. Why the child is repeatedly committing like this? Okay, so that means the error. When we try to identify the error, we should understand like why instead of saying directly this is the urak, we should analyze the student why the child is committing like this. Why the child is writing this answer. Okay, so then try to think in terms of the child thinking process. Where is the mistake? Like why it is. So in that perspective, we need to identify the misconception. Teachers should find out why the child is getting 54 and what they understood about the multiplication. Is the concept of multiplication, whether it is clear, or we misunderstood the concept of the multiplication. In what way the child is misunderstood the concept that we need to identify, rectify that through the diagnosation, and we should provide the alternative remedial teaching, that remedial strategy for to overcome that misconception. Now ask to memorize the table. If you just ask the rote memorize of the table without conceptual clarity, does it help the child to overcome from the errors? No. So understanding the comes before the memorization. Through the memorization of the tables also doesn't make any reduce or minimize the errors, misconception. So conceptual understanding is very much important. So therefore first identify the misconception, provide alternative teaching method in order to overcome this misconception. So option C is the correct answer for this. Now, a student writes 25 centimeters equal to 250 meters. This is mainly whether it is a conceptual error, whether it is a careless error, whether it is a procedural error, whether it's a creative error. Just let us try to recall what is the conceptual error. The student does not understand the meaning of the units, where we have given the two different units we have here. So he does not understand the meaning of the units and the purpose of those units and the relationship, and they think that centimeter meter are the same type of the units and just change the number. This is the misconception about the unit conversion. So where this child has committed the mistake in the conversion of the units, centimeter and meter. Okay, so this is purely based on the conceptual error. So if his child have the understanding the concept of converting this unit conversion from centimeter to meter, okay, so then it doesn't make any error here. So therefore the lagging of the conceptual error, student committing a mistake here. Okay, the option A is the correct one. Now what is option B? Careless error. It does not come under the careless error. Careless error occurs due to the inattention or the slips, like writing 250 instead of the 25. So here he did not write like that. Okay, so here the student is confidently wrong, but not just that careless. Okay, procedural error. Procedural error occurs only when the method or steps are wrong despite knowing the concept. Here the student has not even applied the right concept here. Okay, the creative error. Creative errors involve the original or innovative thinking. This answer is not creative, so the given answer is it doesn't involve any creativity. It is based on the incorrect understanding of the unit conversation. Therefore we say that it is a conceptual error. The correct option is option A is the conceptual error. So now the next one is, which classroom promote the minimum mathematical errors? So the option A is the lecture one, option B is the memorization, option C is the activity based learning, and option D is the dictation. So which is the more classroom which classroom promote, whether lecture type of classroom method, whether it is a memorization or it is activity based learning or it is a dictation. So you can say that activity based learning that help you to minimize the mathematical errors. So how it is, let us see now. In the lecture classroom situation, basically what will happen, students will remain the passive and do not get opportunity to explore a question or apply concepts. During the lecture, where it becomes a one-way way of teaching, where only teacher is teaching here. Okay, so completely like teacher-centered approach. So here what will happen, student remains as a passive learner, so they do not get the opportunity to explore or question or apply the concepts. Second one is the memorization. So therefore this is the wrong. Now rote learning may help in the short-term recall, but does not build understanding that leads to the misconception. So if you memorize the like tables, all those things, it may return only for over a period of time, certain time. Okay, so not for the long-term recall. Long-term it will not be happen. So therefore this is also incorrect. So even if you memorize the tables, there is a chance to minimize. There is no chance to minimize the mathematical errors. Again commit the errors. Now option C is the activity based learning. Okay, so in the activity based learning, where the student get the opportunity to hands-on activities, discussion and manipulative and real life, connecting with the real life situations that help the students to understand the concept deeply and also correct their mistakes. So learning by doing reduces the misconception errors. So this is the way through activity based learning, where students get a lot of opportunity to interact with the based on the activities, interact with the peers and having the discussions, manipulative and connecting with the real life situation, where it becomes a much more better understanding of the concept in a deeper manner, and then from that we try to once the child get the deeper understanding, they try to reduce their mistakes. Okay, then so therefore it's after option C is the correct answer. Now dictation. In the dictation, what will happen basically in the classroom? Dictation basically focuses on only copying information, not understanding. So where the teacher is dictating and student is just copying the notes, whatever the teacher is dictating. So it doesn't make any learning meaningfully here. It does not allow the exploration or correction of the errors. Is there any chance of correcting the errors? It doesn't have the opportunity to correct their errors for their making. Okay, doesn't allow the even exploration in the dictation. So therefore, option C is the correct one. Engage students in activities. Encourage questioning and discussion, use the concrete materials and real life examples, and give feedback, error analysis, promote the conceptual understanding instead of the rote learning. So when when the student learning by doing, it reduces the misconceptions. So active participation always which leads to the better understanding and fewer errors and stronger building the concepts. Then, so with this, we are closing. We'll come up for the end of the session. In this session, so we have discussed error analysis, why students make errors, and how the students overcome from from the errors and personal errors. We also discussed about the variable errors and constant errors, interpretive errors, and we also discussed what systematic errors, and we also discussed types of errors such as conceptual, procedural, careless errors, and we also discussed some of the teaching methods such as inductive method, deductive method, and heuristic method, laboratory method, analytical method, and some of the previous questions which we have discussed. Okay, so with this we are going to close this session, and thank you.